So I want to take this lesson to examine how we sketch these curves. This is the beginning of chapter 8 for us, and so I've separated it, but at the same time linked them together, because we've spent an entire week and a half or so working on just limits. But now how do we take these equations and graph them, even the most odd looking things? So let's take a couple familiar graphs, y equals x squared, y equals x to the fifth, and possibly even a few others that are familiar, and see how we can use the techniques that we know regarding limits, as well as what we know with derivatives, to help us. And so if you remember, whenever you want to graph, we always want to start in the same way. And so our first step is always, we're going to look at positive and negative infinity. And so each chart that we set up is going to have infinity and negative infinity. Now, may I remind you, on the CLEP exam, it will never, and even on our own tests, it will never ask you to graph a function. It may say which graph below is this equation, but more than likely it won't even ask that. It'll instead ask you questions that will force you to graph it, or it will ask you in such a way that the graph would make it easier if you actually know how to do it. And so it is important that we know how to sketch these curves so that we can apply this information and even be able to answer it more appropriately. So, and maybe even faster, especially if there's multiple sets of questions. So, infinity. When we're putting infinity, we're basically saying we want to know what's the last thing this graph is doing to the right, and negative infinity implies what's the last thing it's doing on the left. So we plug in infinity, limit, of course, infinity squared would be infinity, and negative infinity squared would be infinity. Good. Step number 2, and this is important, that you then look for points of horizontal tangency, your favorite thing. Many of you last chapter had a little bit of a rough time with this kind of question. So we're going to look at horizontal tangency. So when is the slope equal to 0? So we're going to find the derivative. And so y prime, so to speak, is going to be 2, right? 2x. And then I'm going to say 2x equals 0, and so x equals 0. So 0 is my point of horizontal tangency. So I plug in 0, 0, 0, right? Easy enough. And we could even go so far, and yes, that is step 3, is to now look to see if there's any points of inflection. And so to find points of inflection, that means the second derivative. So I would take y double prime would then be the derivative of 2x, which is 2. And so does 2 ever equal 0? And of course, no. That means in this case there is no point of inflection. So that means this is all the information I've got. So to graph this thing, we would then draw our axes. 0, 0 is a point. I know that as I go to the right, it's going up to infinity, and as I go to the left, it's going up to infinity. And hopefully that looks very much like what you would expect. Let's look at this next one, y equals x to the fifth. Y equals x to the fifth, again, we're going to set this up with positive and negative infinity. And so infinity to the fifth would be infinity, and negative infinity to the fifth would be negative infinity. Okay, so now step 2, points of horizontal tangency. How do you do that? The derivative set equal to 0. So the derivative of this would be 5x to the fourth, and we're going to set that equal to 0. And so I would divide by 5, and I get x to the fourth equals 0. And so you do the fourth root, and guess what? You get 0. And so we have 0, you plug in 0, 0 to the fifth is still 0. Then you do the points of inflection, so you get 20x cubed, and you set that equal to 0. And it says, just wait a minute, x cubed equals 0, and so x would also be 0, indicating that this is also a point of inflection. Interesting. And so when you plug 0 in, you get 0, 0. And so what that means to you as you're graphing this then is that not only is 0, 0 a point of horizontal tangency, so it's coming in flat, but it is also a point of inflection where it's changing from concave up to concave down. Now later you'll find we'll even be able to ask questions like when is it concave down and concave up, which we've already addressed in previous chapters when we were doing that derivative section, if you remember. And so maybe this isn't enough information, but the truth is you know it's changing in concavity. You know it's got to go to negative infinity as we go to the left, and it's got to go to positive infinity as we go to the right. And so whether it does it at a slow rate, kind of like the log, and I don't want to mess you up too much, but the truth is this, okay, could be one way, and this, but the problem with that is that vertical slope. And we know that there's a derivative at 0. We know there's a point of horizontal tangency. And so that makes us know that that has to look that way. But we could also determine it by looking at the second derivative and understanding its concavity, positive and negative. Okay, let's look at a few more examples today. We have the fourth root of x, something we're not quite as familiar with. So let's start again. We have our infinity, and we have our negative infinity. And so go ahead and plug those in. The fourth root of infinity would be infinity, and the fourth root of negative infinity. What do we find with that? It's not possible. This would be imaginary, indicating something's going on there. Okay? It must not have a negative infinity. It must not be going in that direction. At some point, this thing is going to stop. In fact, we can't have any negative numbers. And so this tells us there's no negatives, because we can't do the fourth root of them. It goes into the imaginary realm, and that's not, of course, what we're graphing. We're graphing in the real number system. So now we're going to do points of horizontal tangency. It does help to look at this equation as x to the 1/4 when we do our derivative. And so let's do that. Do 1/4 x to the negative 3/4. Good. And again, it does help when we actually look at this in its right form. So we would have the fourth root of x cubed, and that would be on the bottom because of that negative exponent, and that 4 would also be on the bottom. And we want to know when this will equal 0. Well, this is a fraction, right? And when do fractions equal 0? The only way a fraction can equal 0 is if the top equals 0. It's certainly not when the bottom equals 0, right? Because that makes it undefined, which tells me then there are no points of horizontal tangency. It must mean that it's a vertical tangency or something's going on there. Well, let's do a second derivative, because that's the next part of this. That didn't give me very much information. So now we're going to do a second derivative. So this negative 3/4 is going to drop down, right, making that negative 3/16. X goes down again, right? And tuck this away here. And it goes down again, which makes this now negative 7/4, right? And we want to set that equal to 0. Okay, so let's do that. And so when we solve that, we have negative, I'm going to just rewrite it over here, negative 3/16, and we have the fourth root of x to the 7th. And so when would this equal 0? Again, no second derivative, so there's no point of inflection. So it's not an inflection point. It's not a point of horizontal tangency, so what is going on there? Well, that's where, what I was talking about previously, it helps to look at the second derivative in terms of when is this thing, what kind of concavity am I looking at? I understand that my graph has something going on here at 0 to the point at which 0, we can do the fourth root of 0, so we must have a point there, and we know it's going to infinity. Is this going to be concave up, like this, to infinity, or is it going to be concave down, so to speak, and so it's still climbing, kind of like the natural log or the log graphs? Which one is it going to be? And so that's what we have to figure out. To do so, you want to look at the second derivative. And so to look at the second derivative, all right, back to our little guy here, or this version, whichever one you want to look at, and say to yourself, okay, when is this going to be positive, or is it always going to be negative? Now, what numbers do we put inside here? We've already talked about the fact that you can't take the fourth root of a negative number. And so therefore, if we put a negative number in here, it will remain negative because that's 7th power, and so the fourth root can't be done. So we're never going to put a negative number in there. it's always going to be a positive number. And that means that this value here on the bottom would be positive. So I would have a negative divided by a positive, which means overall this will always be negative, which means that this graph will always be concave down. And so it is just as we expect. It has that vertical, right? Now it should also help, by the way, as I was pointing out about the horizontal tangency. If it was bent the opposite direction, then it would have found to have a horizontal tangency at 0, and it does not. So those two things combined should confirm to you that it is in fact concave down, like you see here, and it has a vertical tangency there. So that's why the problem. It doesn't have a slope at that spot. So hopefully that clears that up for you. Now let's look at another one. Y equals 3x minus x cubed. Okay, here we start again. Infinity and negative infinity. I encourage you too, as you're watching this video, feel free to stop it and do these on your own, and I'm just going to continue on explaining them, but feel free to try some of these by yourself and then see if you're right. And then if you get stuck, feel free to jump back in. If I put infinity in here, I'd have infinity minus infinity cubed, so that'd give me negative infinity. I put negative infinity cubed would be negative, but the negative in front there makes that now a positive infinity. So now we're going to do the first derivative, and so y prime would be 3 minus 3x squared, and we're going to set that equal to 0, and we're going to solve that. And so I have x squared equals 1, and so x equals plus or minus 1. Please don't forget the plus or minus. You'll also notice that I'm really careful to put these in chronological order. I will put the positive one closer to positive infinity and the negative one to negative infinity. And we certainly can evaluate that. So that'd be 3 minus 1, or 2. And if I put negative 1 in there, that'd be negative 3 minus a negative 1, so that becomes plus 1. And so that would be a negative 2. All right, let's do our second derivative and see what happens with that. If I do the second derivative, y double prime, in other words, we're going to look right at this, and we're going to do the derivative of it. The 3 goes away, and it becomes minus 6x. And so I set that equal to 0, and I find that, oh, 0 must be a point of inflection. To plug that in, I end up with 0, 0. So now let's try to take shape with this graph. The graph, we understand that 0, 0. That's a point of inflection. That does not mean it's a point of horizontal tangency, so I don't want to come in at that flat. But I do understand that 1, 2, and negative 1, negative 2 are points of horizontal tangency. And so when I come at these, I actually want to come at them flat. As I go to infinity, it's going to go down. And as I go to positive or negative infinity, it's going to go up. And so that would be your graph for that. Last graph I want to do with you today is the 1 over x plus x over x minus 1. This is quite involved, and this will take quite a few minutes, so hopefully it won't exceed your ability, but it's certainly, we want to make sure we go over a question like this. So, first things first, we're going to plug infinity in this. And we're going to plug negative infinity in here. So when we plug infinity into this, I have 1 over infinity, and then I have infinity over infinity. Two separate indeterminate forms, or can be anyway. Infinity over infinity, we take the highest power at the top and the bottom, we have x over x, which actually equals 1. 1 over infinity, what of course is that? That's 0, right? And 0 plus 1 is 1. Now if it helps to put the 1 plus and the 1 minus, feel free. But I'm going to, again, do the negative infinity at the same time. The negative infinities become positive 1. And this technically is 0 minus, so certainly we could put that 1 minus. But I'm just going to leave it at just the 1s at this point. And hopefully that makes sense to you. Moving right along, we're going to do its derivative. And this derivative for this becomes a little tricky because the way you want to look at it, of course, is that this is x to the negative 1 plus, right? And this would involve the quotient rule. And so if I'm going to do the derivative of x to the negative 1, let's do that up here. That becomes negative 1 x to the negative 2. And I'll put that as negative 1 over x squared. And with our quotient rule, what we would have is the first, or sorry, low times the derivative of high, which is 1, minus high times the derivative of low, which is 1, all over low squared. So that's x minus 1 squared. And so continuing on with this, maybe you want to simplify that up a little bit. X minus 1 minus x right? And so the x's would end up canceling out. And so I have minus 1 over x minus 1 squared. Again, I want to know when this thing equals 0, right? I want to know what's going to make this guy equal to 0. And that, of course, it doesn't happen because it's a fraction. Now, there's something I should remind you of that maybe you might have forgotten at this point. But one of the things that we did last year in pre-calc was when we're doing these questions, you actually want to look at what's going to make this have a problem. What are your problem points? And even though we've already kind of surpassed that step and started going to the points of horizontal tangent inflection, we've not gotten past this because the truth is 0 is a problem point because that's what makes this undefined. So one of the points of interest is 0. And also 1's going to make this denominator undefined. So what we do is we look at 1 plus and 1 minus and 0 plus and 0 minus. And that's actually where you're going to get most of your information for this. In fact, that's where you're going to get all of them. Because you're going to do the second derivative, and guess what? Everything's going to be in the denominator still, and it's not going to give you a point of inflection either. So we're kind of stuck. So let's do it up. Let's actually get this going. When we put 1 plus in here, that means I have 1 over 1 plus. That does nothing to this. This just equals 1. Plus 1 over 1 plus minus 1. That means that that is 1 over 0 plus or infinity. And so, of course, infinity plus 1. That's still infinity. If I put 1 minus in here, understand that that really doesn't change that 1 here in the beginning. But it does certainly change this to be 0 minus. And so that would be negative infinity. In a similar fashion, the truth is the only one that really mattered in this particular question was this one because it's the one where the denominator was 0. But in the next part where you have 0 plus, well, that's really affecting the first one because the 1 over 0 plus and the 1 over 0 minus is what's affecting that one. But when I put 0 into the next one, well, that's just 0 divided by negative 1 and 0 divided by 9. So that's, again, that's not affecting that second fraction at all. I really am just focusing on that first fraction for this one because that's the one that's undefined with the 0. So this is infinity and this is negative infinity. When you do the graph, what does that mean? If you recall, what this basically means is we're going to group these by section. You remember this? And so when you group these by section, what that looks like here is that at 1, we're going to have an asymptote. And then at 0, you're going to have another asymptote. And so 1 plus means 1 to the right. So we're going to go 1, and we're going to go just to the right of 1, and that means it's going to infinity or up. And as I go to infinity, I'm approaching 1. So there's also a horizontal tangency of 1. So it's going to approach 1. And if you remember, that was 1 plus, and so it would be on the top side of that. In a similar way, I'm going to jump right down here to the bottom. You have 0 minus. Let's just look at 0 minus. 0 to the minus, 0 minus, that means to the left. It's going to negative infinity. And negative infinity, as the far left, we're going to go to 1. And if you remember, that was 1 minus. So it should make sense. Okay, now we've got these two here right smack dab in the middle. 1 minus, 1 to the left means it's going down to negative infinity. But 0 plus, or just to the right, goes to positive infinity. And so we do, in fact. Now, looking at this, you can see there is a point of inflection here. But really, to get the gist of the graph, you would have to do, you'd have to look at these limits like I'm seeing here. And you could certainly do the second derivative, and I would only do that in extreme cases if that's what they were asking for. So there you have it. There's those graphs, and seeing how to sketch a graph. This is going to get quite involved and certainly applies all the limits we've learned so far. So hopefully this is at least enough clarification for these odd ones with the x's in the denominator, as well as even the power ones that can be a little tricky at times.